guys, so I just wanted to give you another ImageJ tutorial, kind of a quick version that walked you through the different types of observations that you can make using the ImageJ software. I'm going to be using the browser version for this software, so this is just the link that I've provided you before, which allows you to use the ImageJ software without downloading it onto your device. However, if you do download it to your device, then you can do a couple of extra things with it, which is nice. So I'm just going to be working with the browser version since that's the one that most people are using nowadays. So the first thing you want to do is obviously open up your image that you're going to be looking at. So I've downloaded a couple of images that I can look at. So it's going to say, what do you want? I already downloaded them on my device, so I'm just going to open up one of these. And then you can open up all your images at the same time. They should tell the name on top, so it's not like it's a problem. I'm going to be looking at two different ones to show you two different sets of information. These are both taken using the 40x objective lens, so you can kind of see the difference in the size of the cell in these two, right, up front. It's just amazing how different the same cell line looks with a different treatment. So this one is black mulberry treated, and these are some Taxol treated cells. So I'm going to go ahead and show you some things that we can do with these images. So I'm going to focus on just this one for now. I'm going to actually put them right behind each other so that I can focus on this. It's specifically. So we've talked about some basic observations already in the previous lab. One of the basic things we can do is just count total number of cells, total number of nuclei using this multi-point tool. And that's a very cool, easy way to do that. And with the multi-point tool, if you double click on this, I can make it into whichever way I like to see those dots or circles or crosses. So I'm just going to make it whichever one right now. I do like it to label them as either 1 or 2 for nucleus versus the cell, and for your interesting observation as well. So if you're making an observation regarding number of nucleoli or number of cells with vacuoles or number of dividing cells, that can be a category 3. You can have all those on the same image, which is great. So I'm going to show you how that's going to work. So I put it on 1, and that's going to be my number of cells in this particular field, or this particular image. Now this one has a bunch of cells. Maybe I'll use the other one because I just want to give you the idea on how it's going to work, right? They're both at the same resolution, which really doesn't matter for this part. Now, this is actually a good image to use. Since some of these are going to have many nuclei inside, you want to be able to see them. So one of the things that you might want to do is go into Image, adjust brightness and contrast. And when you do that, you can have an auto setting if you want to try that. Sometimes that's sufficient and that gives you a lot of clarity. Other times that's not quite what you like, and then you can play around with the brightness and contrast yourself and get it to be where you feel comfortable with it yourself, right? So I want to make sure that I'm looking at all the nuclei and the cells well. So I just reset it because I didn't like what I saw. I'm just going to adjust the brightness a little bit so I can see the nuclei very well, and then maybe a little bit of the contrast so I can still see all the cell membranes without them getting hidden. And then once I'm happy with it, I will just say apply, and then it will set it there. Now, using that multi-point tool, I can go ahead and count my cells. So I'm going to be putting this, in the cells. Wherever there is a cell body, that's going to be a cell, right? You want to make sure that it is a cell that's pretty much present in its entirety if you're going to be measuring it, especially This field had very few cells, obviously, so I still used this one, but normally we would not be using those. And then if you put one where there shouldn't be one, you can always move it or delete it. So okay. So you can measure each one of these cells based on their position on your field. That's one of the things that it allows you to do. We're not going to be utilizing that quite yet because we're not looking at movements of cells or looking at where they are in that space. It doesn't really matter to us, so we're not going to worry about that for now. Okay, so now that we have all our cells, we can go ahead and we can look at the next category, right? So I'm going to go ahead and count the number of nuclei. And so I'm going to go back and I'm going to go to category 2, right? And I want to make them a little bit bigger. They seem really tiny right now. And click OK. And now I can go ahead and measure my nuclei. So I'm just making sure it's on 2. Yes. And so here you have a nucleus. I'm going to count that. This one, I can't really visibly see a nucleus in here or in here. I do see one here. This one has a bunch of nuclei, right? So you're going to try to make the best judgment. You can expand them, right? You can use this tool to make it bigger so you can look at them better, right? And then you can continue to count your nuclei. So some of these on the outside the nuclear membrane, those are, that's just cytoplasm. All of these are actually nuclei inside, right? So you see a bunch of these nuclei in there. And using this tool, I could view, zoom out and go back to my reset zoom and go back to my full image. So that's a great thing. Now, some of these cells, they are not going to have the full nuclei. The cell body is not fully there, but you do see some of the nuclei fully there. So that means that I can still utilize those nuclei in my counts, right? And so I will continue to look through and find any other nuclei that might be present there. I think I got most of these nuclei. There's some in here that I can see, and I know in your screen it may not be very visible, but there are 3 that I can see very well inside. There's one here, there are 2 here. So that would be my second count. This is number of nuclei that are present. Now maybe the third observation that I'm going to make is how many of these cells were either anucleated, that is, they did not have a nucleus, or that they were multinucleated, had a lot of nuclei inside, right? That's another thing I can make observations on, so I would double click on this again. I lost my chart because it went back. Let's get it out. Sometimes that happens, it goes behind your screen and you don't see it, especially if you're magnifying and reducing. So you want to make sure that you go back and find him. And then now I'm going to go to category 3. And I can, like observations on my interesting observation, right? So in this case, maybe I'm marking cells that are multinucleated, or I'm marking cells that have these long projections, right? There are a couple of cells like that. So I'll just do the multinucleated. That seems like a good one to do. And I'm going to mark them. This one. I already did that. This one over here had multinucleated. So those would be the ones that have multiple nuclei. And then once I've marked those cells, now I have this image completely done with all of the observations that I wanted to do as far as counts are concerned. So one of the things that I would like you to do at this point is take a screenshot essentially of your screen by you can use the print screen function on your device, and then go into a brand new PowerPoint. You're gonna have 4 slides at the end of the day in there, so I want to make sure that it has like a title only, so you can write down which sample it was. This in case is my Taxol sample, so I'm just gonna write Taxol 1 or whichever one I used, and then I'm gonna paste that print screen there. I'm gonna crop out everything except the image with its title visible, so I know which image I was using, right? And that's gonna give me a screenshot of what you counted, right? And how you observe these cells. And it's gonna allow me to figure out if you were making a mistake or if everything was being looked at correctly. So I do want you to give me a slide like this for each one of your sample. So you'll just have one image, right? And the final, for the remote students, obviously, are looking at all your images like that. You're just choosing one of your untreated to show me how you counted, one of your black mulberry, one of your Taxol, one of your saffron. So there'll be 4 slides total, each one by each of the students that are making those observations, looking at how you counted your samples, okay? And then obviously I need to have some information about these, right? You want to make sure that you let me know what is what. I can guess, which is fine, but it's always better if you give me a clear information, some type of clear information about what it is that you were calling as your cell or anything else. So all that needs is a little text box that says, you know, category 1 or blue color, whichever one it is, however you want to put it, the cells, 2 are the nuclei, 3 are multinucleated cells, right? So that very clearly tells me what it is that you were observing within this picture. You can even make it a little bit more informative as far as you are concerned. You could do it, you can make a PowerPoint like this with all your images and use it for additional kind of data categorization and data collection, where you can even write down those counts in front of these so that you know what you counted or what you saw in your counts. So here I can see number 3. There are 6 multinucleated cells, there are 26 nuclei, and there are 11 cells in this particular image. So I could write n equals 11. You could write n equals 26. And over here, n equals 3, right? So I know there were more than 1, 2, 3, 4, 5. There should have been 5, 6 cells that were multinucleated. Let's go back to the counter and make sure, based on your counts, that you got those correct. 1, 2, 26. Oh, 6. Sorry, it is 6. I didn't read that correctly, did I? So n equals 6, right? So now I can even see that information right up here. You can use this information later on for other things as well. Here's the other thing that you can do here. If you were using it for data collection, you would do that for each one of your 3 or 4 images. 3 images in your set that you are using for your main fields, 1, 2, and 3, and 1 from that other set that you will use to compare your data to another groups with that 4th ImageJ slide. So you could even put your measurements here once you collect them. Now to make your measurements, you're going to be making the measurements of 3 cells in each of your fields, 3 to 4 cells in each of your fields. To do that, I'm just going to go to the segment, line segment function. And when I do it, it's going to say, well, you need to remove it. So you want to make sure that you get that screenshot before you clear all the selections, right? So I'm going to just say selection, select all. and then delete the 43 points. Now to make our measurements, you need to have the measurements in micrometer. So if you were using the front microscope and you know your calibration already, you could go to Analyze and Set Scale and go ahead and set that calibration. I believe it was 2.4 maybe. I am making this up, so please do not take that. You would need to look it up in your actual sheet from Microscopy Workshop and see what it is. If you don't have the calibration for the images you have, because it was done using the side microscope, you would need to recalibrate using the calibration image provided to you for the side microscope. Same thing, if you can't find your Microscopy Workshop sheet or aren't sure if that was correct, just download this particular scale, and then you can go ahead and calibrate, and you can go ahead and do what you need to do. And so going back to our ImageJ, I'm going to go ahead and put my scale 2.4 micrometer for 2.4 pixels per 1 micrometer. That's the scale. I hit global because all my images are going to be from the same microscope, same calibration, same scale. And I am going to make sure to expand it and click OK, so it accepts that and saves it. Now I can measure. And for each of my measurements, I am going to take the measurement from the long side of the cell, right? I made that line, and I'm going to say measure, and it is going to measure it in micrometers, right? And tell me the length of that cell. Then for the nucleus itself, again, same thing. I'm going to match them, so I'm going to have the cell and its nucleus, cell and its nucleus, just to make it easier. And then go to Analyze, Measure, and there's my nucleus for this particular cell. Here is a small cell, right? And for cells with projections, you're only going to worry about the actual cytoplasmic cell body portion of it and not worry about the projection. So for this one, I guess this side maybe would be the longest, and I will say measure, and then I will go back and I will look at the nuclear size. Oh, that seems a little long. There. And then Analyze, Measure, right? And now I'm getting all those cell measurements. And then I'm going to take another last cell. Oh, this one did have a lot of nuclei as well. I did not look at them very carefully. So it was something that I missed. And again, I can go back and I can add those to my counts. Measure. And then I'm going to take one of those nuclei to measure. It doesn't matter. You can kind of pick a typical one and measure those. So now I have all my measurements for this one place, right? I can do Save As, and it's going to give it to me as a Excel sheet. And that's great, because then you can have all these numbers available in Excel as well, and they will have that information available. So you can say, sure, results for, and you would just label it as some number, as the name of the image, so that you know which results these are, right? And it's going to export them out to you as an Excel file. You can also write these numbers down in the sheet that is provided to you for the three, in that chart with the cell measurements. You're going to write this one, in my case, right? Every other one is a cell measurement. So I'm going to go ahead and I'm going to select my 3 cell measurements and color them so I know these are my cell measurements, and then I'll have my other 3 measurements. Those are my nuclear measurement. Now here is an interesting thing. I can actually have other measurements as well that I can make with Excel, okay? Yes, just replace it for now. So I'm going to continue with this image, and I'm going to show you a couple other things that I can do. One of the things that I can do is I can look at the image, and I can look at a couple of different types of things. So one is the shape of the cell, the circularity of the cell, that is called. And then the second one is looking at the area of the cell, how much volume or area that has. For the area calculation, you would take this freehand selection, right? And you would draw out the outline of your cell. So it takes a little bit of practice, unless you have one of those like little pens, right, with your thing. And I kind of went a little bit over underneath. I did very good other than that. So I'm going to do it one more time. And you want to try to be as good about it as possible. And this is something you could do if you have one particular treatment that is really showing a difference. That's something interesting that you can observe, is the number or the volume of cells or the area of cells. And here, when I measure it, you see right here, it's giving me the area of my cell. Okay, and this area is then going to help me. You can compare that between different treatments or different types of cells, different categories of cells. And so when we do that, we also take into account these measurements and these exons as well. You could do that, right? Now, to keep track of which cell you've already measured, and you don't want to go back and accidentally do it again, one of the things you can do to it is to go to Edit and Fill It, and it's just going to color it in, and then you know that this is a cell that you've already measured, and you don't accidentally go back and do it again. And then I could go to a different one, in this case this simple round one, and I could go and measure that, and it's going to give me that number as well. Okay, so I'm just going to go back for a second to set scale and make sure that it is indeed giving it to me in micrometer, and it is. Good. So that's how you can do an area measurement. The other thing you can do with them is just measure the length of a projection, for example, right? So I can again draw out using my line tool, right? And I can look at the extensions, and I can measure them, right? And then it's going to tell me in the final length how long that projection was, right? That's another thing you can do with it. So there are many types of measurements that you could make with your ImageJ. Another thing that we can do is what we call the circularity of the cell. And you can find that in here. Okay, so to do some of those, you can go to Analyze, Set Measurements. And in this tool, you will notice there are a lot of things that you can choose. And so you can make shape descriptors as one of the things you wanted to calculate. You can tell it to look at, for example, fit an ellipse, look at the area fraction. There are different things that you can add to your measurements so that it can give you additional information about your samples. So we're going to go ahead and we're going to look at these, and for now, click on OK. You can even have standard deviation, so it's going to talk about where different amount, how much variability in the size and the shapes are there in the sample as well. And then it can calculate medians and other things as well. So for now, we're just going to click a few more. So I want shape descriptors in there. That's the biggest one that I would like you to try if you wanted to look at different shapes, for example. And then you could do some of these other ones as well. And so now I'm going to go back and I'm going to do those shapes again, right? So let's say that I am now selecting this particular cell as one of my cells, right? And I'm going to do 3 different cells with 3 different shapes, and we can compare them. And so when I measure this time, it's going to provide me with a lot more things than just what we did, right? So it's giving me the area, perimeter. It's going to give me the major measurement, the minor. So it's going to give me both sides measurements, right? So it's not just one-sided anymore like we did before. It's also going to give me the circularity. This is something that is useful, and or you can look at the roundness of the cell, either way. So it's going to give me a few different things about the cell. Okay, now let's compare that to something else. Let's look, for example, at this cell that's pretty round, and see how that number is going to change. And now I'll just go to Analyze Measure again, and you can see how this one's going to have higher number, closer to 1 for the roundness. Now let's compare that to maybe this one. And I'm not drawing it out very well, but you see how this one has a lot of projections. Looks like a neuron instead of a cell, but just to kind of show you the difference. And like I said, I'm not doing a very good job right now for it, but just to show you. And we do an Analyze Measure. And now you see the circularity went down, the roundness went down, the solidity went down because it has these long extensions, right? So these are other criteria, other things that you can look at if you think there's going to be a significant difference between your different treatments in regard to the shape of the cell, or the area of the cell, or the solidity of the cell, any of those things. So here's one more. We'll do this one last one. Sorry, I did not mean to do that. Measure. And now again, you see that these ones are going to give very different results, right? So each one of these, this was a small cell, and the circularity for this one was a lot smaller. The circularity for that one was a lot different. And so these are some different types of measurements that you can make with ImageJ that are not typically able, that some of which we are not able to do with just typical microscopy by itself without the help of a computer software like this. So you can, since especially for those labs that are remote this week, my Wednesday, Thursday, and Friday sections, definitely want to take advantage of the fact that, okay, you didn't get to experience microscopy quite the same way as you wanted to, which we still will get to do. We have other labs that are going to utilize microscopes as well, but at least you can then get more comfortable with ImageJ and do some of those more higher level functions and explore those functions in there when you look at those interesting observations. In next week's lab, we are going to be utilizing the data that you collect this week. So that's why we are continuing to stay on track with it, because we need this data in order to do next week's lab. But we will have time in class for you to visit the actual slides. I have all the slides saved for all the sections that we have prepared, or that you students have prepared yourselves, for example, Monday and Tuesday. And we will have the slides available for you to look at, to kind of have a physical experience with them as well next week, and then definitely in a couple of weeks when we go back into cell viability. So you will get to experience them with the microscope as well. In the meantime, you can explore ImageJ and get all the data that you need through that. I hope that helped. If you have any questions, just send me an email, or send Professor Jennifer an email. Either way, we will be able to help you out and help you with whatever it is that you're having trouble with. Stay safe. Take care. Bye-bye.